All right, guys, our last part of these solving trig equations notes deals with, I guess, another issue, just like we solved using identities, but identities aren't going to help us here, okay? Um, so what we're going to want to do here, let's take a look at 4. We're going to be solving here, but we have a 3 theta, okay? So what we're going to do is we're going to start by getting the trig equation by itself. Okay, so nothing's going to change here. We're going to get that trig equation by itself, the sine of 3 theta. Here's what we're not going to be able to do. Divide by 3 to make it a theta. Can't do that. Okay, so let's start with kind of step A here, getting the trig equation by itself. Let's add 1 to both sides. Let's divide by 2. All right, awesome. Okay, so what we're going to do, we're going to treat this momentarily we're going to treat similar to if this said theta. Thinking about our original domain, 0 to 2 pi. Okay, I really should put original domain given. Okay. All right, so let's do this. Forgetting that there's a 3 theta here, okay? Sine values are 1/2. We're thinking quadrants 1. We're thinking quadrant 2. We're thinking 30-degree reference angles. And we continue on by saying that the angles would be pi over 6 and 5 pi over 6. Now, if this just said sine of theta, we'd be done. Theta would equal those two. Here, we're not solving for theta. We're actually solving for 3 theta. Okay? All right, now, when we deal with something other than theta, there's going to be more than the normal amount of solutions, if you will. If this just said sine of theta, we'd stop with our 2 solutions. We have sine of 3 theta. You know, you can think that there's actually going to be 3 times as many solutions here, okay, that we would normally have, all right? So here's what we're going to do. Instead of treating it as 0 to 2 pi, we're now going to add on that 2 pi k. Okay. This would represent all of the solutions that would be possible. Now, I know it doesn't say that here. It's just 0 to 2 pi. But when we're using, or when we're solving a trig equation with something other than a theta, when we do the inverse sine, when we find the angles, but a theta doesn't come out, maybe a 2 theta or a 3 theta or a 5 theta or a 10 theta for that matter, okay? We're going to think about all the possible solutions, and then we're going to kind of narrow it down. Now, forgetting about what's on the right side of this equation, let's forget about this part for a second. Algebra would tell us that if I want to solve for theta, and I have an equation that says 3 times theta, we're going to divide by 3. We're going to divide everything by 3, including that plus 2 pi k. So now theta is going to equal pi over 18, or 5 pi over 18, plus 2 pi over 3 k, where k is an integer. Okay. And here's what we're going to do. We're going to check just to make sure these answers actually fall within our domain. Are these 2 answers between 0 and 2 pi? They absolutely are. I'm going to circle them. These are going to be 2 of the answers that I want. Okay, they're kind of our original 2 answers, if you will. Okay. But I do also want to check this plus 2 pi over 3k to see if there's more answers, and there will be, and you guys will start to get the hang of this. Like I said, that 3 theta can mean in our heads that there's going to be 3 times as many answers, or 6 here. Okay, so the next thing we're going to do is let's plug in when k equals 1. When k equals 1, I'm going to add 2 pi over 3 to both of these answers. Now, 2 pi over 3 is equal to 12 pi over 18. Okay. All right, common denominators to actually add. So if I add 12 pi over 18, I would get 13 pi over 18, and I would get 17 pi over 18. Okay. Let's check. Are those still within our domain? They certainly are. Let's circle them. Those are going to be two more of our answers of really the 6 that we're looking for. How about when k equals 2? Okay, if we add 2 pi over 3, basically twice. Okay, well, 4 pi over 3 is 24 pi over 18, or let's just think about adding another 12 pi over 18 here. We'd get 25 pi over 18. We'd get 29 pi over 18. Are these both within our domain? Well, 2 pi is 36 pi over 18, so that does fall between 0 and 2 pi. Those are going to be our solutions. I know as the teacher who's done lots of problems like this, that that's going to be it. That's where we're going to stop. If you'd like to check k equals 3 and see that that's 37 pi over 18, which is greater than 36 pi over 18, and 41 pi over 18, again greater, we basically get to stop at these 6 solutions. So our final solutions, those 6. I knew they were going to be 6 because I had a 3 theta. Actually, more accurately, I knew there would be 3 times as many answers that we would normally find when sine is 1/2. Okay, let's say this would have been sine equals 1. Well, normally there's one angle around the unit circle where the sine value is 1. If it was 3 theta, 3 times the quote-unquote normal amount, maybe we'd get 3 solutions there, and we would. Okay. All right, awesome. Okay, so let's recap what we did there. We got the trig function by itself. Okay, we treated it similar to theta. We were thinking 0 to 2 pi, and we found our angles. In this case, we found our pi over 6 and 5 pi over 6. Then we found all possible solutions. Okay. We divided both sides by 3, and we tacked on that plus 2 pi k for all the possible solutions. Then we solved for theta. In this case, we're going to be either multiplying or dividing. Okay. And then we tested k values for more solutions within our domain. All right, those are the steps for solving when we're given something other than a theta. We were given a 3 theta here. Let's walk it through one more time. We got the trig function by itself using algebra. We found the first two, one rotation around the unit circle, where sine would equal 1/2. That was pi over 6 and 5 pi over 6. Then we thought about all the possible solutions because we knew that there were going to be more. Okay, so we added that plus 2 pi k. We then solved for theta by dividing both sides of our equation by 3. We found our first two solutions were pi over 18 and 5 pi over 18. All the possible solutions would be these two plus 2 pi over 3k. We checked to make sure the first two were in our domain. Check, check. I then plugged in k equals 1. Check that those were part of our domain. They were between 0 and 2 pi. And I plugged in k equals 2. And we'd keep going as long as we find more angles that are in our domain. It happens to be when we plug in k equals 3. These two fall outside of the domain, so we kind of stop with k equals 2. We talked about how a 3 theta would create 3 times as many solutions as we would normally have. Normally, sine theta equals 1/2 would give us 2 solutions. Sine 3 theta equals 1/2 ended up giving us 6 solutions. And we can do a similar thing here. Step A, get the trig function by itself. We have a theta over 2. Okay, so we have a different angle than theta, not going to be a big deal. We're going to follow the steps that we had. So getting our trig function by itself, add root 3, divide by 2. Okay. B, we're going to find the angle measures where cosine is root 3 over 2. Okay, cosine's positive. Cosine's positive in quadrants 1 and 4. Cosine's root 3 over 2 at 30-degree reference angles. By the way, let's change this to 2 pi. There's no reason for us to do 4 pi. Okay, or change that to 2 pi, and that's how we'll ask our questions and problems like this, even on assessments. So that's at 30-degree reference angles, quadrant 1, quadrant 4. So our angles, our solutions, would be theta over 2 is going to equal pi over 6 and 11 pi over 6. Okay, and then part C, we're going to add in that plus 2 pi k, where k is an integer. Okay. Normally we solve for theta. Here we're solving for theta over 2. So let's multiply both sides by 2 to get the theta by itself. I'll multiply all of this by 2. So theta equals pi over 3 and 11 pi over 3 plus 4 pi k, where k is an integer. That's step D of our process. So we got step A, we got step B, we added that 2 pi k, step C. We then solved for theta using algebra. Now, let's check our domain. Between 0 and 2 pi, that was my adjustment there. Pi over 3 is between 0 and 2 pi. 11 pi over 3 is not between 0 and 2 pi. We don't have to check any other answers here. Here, we're done. Not needed. We don't need to test any more k values. Plug in k equals 1. Go ahead. We're just adding 4 pi to this answer, and it's not going to be in the domain. So, our answer, just 5 over 3. Okay? These are traditionally the problems that our students struggle with the most. However, I think you guys will be okay. Stick with our plan. Okay? Get the trig function by itself. Okay? Use inverse to find our solutions. Think about all the possible solutions by adding that plus 2 pi k. Solve for theta, and then start testing your k values if needed. All right, and start to play the game a little bit. 3 theta had 3 times the normal amount of solutions. In that case, there were 6. Theta over 2 had half the normal amount of solutions. All right, so you'll start to get the hang of it.